Okay, today we're going to be focusing on roller coasters, and you have seen the roller coaster physics video, and now you're going to be able to design your own roller coaster, which is going to be fun. So you can see I've got mine here. You know, it's kind of boring. It's got the first hill and then two more hills after that, and you can see I've labeled it with a couple things: the height of the first hill, the mass of the car. And then a couple positions. I chose like 4 or 5 different positions along the ride and just gave it an arbitrary height. So the first hill is 80 meters, this one is 20, this one here is 40, and then I just chose a point somewhere along the way there that was 30 meters. Now, what you want to do is you're always going to get your total mechanical energy, TME, the total energy, which on this worksheet, by the way, is labeled as ME. That's okay. So that just means total energy when you see those capital letters. ME means total energy for the whole ride. You're going to find your total energy for the whole ride by looking at the initial hill. So let's go ahead and put in the information for what's going on at the initial hill, because this ride is going to get all of its energy from how high off the ground it is. So the mass is 200. The height is 80. The velocity is 0. The potential energy, you take mass times gravity times height, and when you do that, you get a big giant number. So mass times gravity times height. So I'm going to take 200 times 9.8 times 80. And I get 156,800 joules. And that's what you're going to put in right there. 156,800. The kinetic energy. Now the kinetic energy, since the velocity at the top is 0, the kinetic energy is going to be 0. And to find the total mechanical energy, so the total energy for the ride, you're just going to do your potential energy plus your kinetic energy. So you would take your 156,800 plus 0. So I get 156,800 goes in that slot there. And then you're going to move along in that same capacity to fill out this bottom chart here. So let's go ahead and do that. Of course, you want to make sure you have a calculator ready. So if you haven't gotten out your calculator yet, go ahead and pause the video and get out your calculator so that you can practice doing this. Now the mass does not change the whole way through, so this is 200 all the way down. You should use the zoom factor on your iPad if you're in the iPad class, and of course if you are in the other physics class, you have an actual piece of paper in front of you, so it's much easier to write on than this tiny screen that I have here. So make sure you're filling in the numbers nice and neat. Fill in the heights for each position. Height at position 1 is 0. Height at position 2 is 20, 0, 40, and 30. Now you're going to do the same thing. For potential energy, you're going to just go ahead and do mass times gravity times height for each of those positions. So for example, for position 2, I would do mass times gravity times height, which would be 200 times 9.8 times a height of 20. And when I do that, this is for position 2, I get a potential energy of 39,200. 39,200. And my total energy from part 1 here is going to be the same all the way down this row. So you can fill that number in all the way down. The 156,800 goes in all the way down that row. Now to find the kinetic energy, we're still working on position 2, just as an example. You're going to go ahead and take that total energy, which is this number right here, and subtract your potential energy. Because like we said before, your total energy is potential plus kinetic. So if I know my potential and I know my total, which I do, I can just subtract those two to get my kinetic energy. And when you take 39,200 away from 156,800, this is position 2, you get 117,600. Now, to find the velocity for that position, you just follow the formula that I have written there. It's from the kinetic energy formula, 1/2 mv squared. And then all I did is I just solved for velocity. So you're going to go ahead and do, let me put a little line here. You're going to do 2 times 117,600 divided by the mass of 200, and then take all of that under the square root. And when you do that, you should end up with an answer of 34 meters per second for position 2. Now, I have an image of the entire key for this. Is the last slide of the slideshow. So I want you to work on this on your own and fill in this chart, and then you can check it at the end of this video. There's a snapshot of the answer key so that you can see if you did it correctly. Now, your goal is to basically do that exact same thing, the worksheet that you just did, except you are going to create your own roller coaster. So as you can see, I've created my own roller coaster here, very boring. You, of course, are going to come up with something much more exciting than that. And what you're going to do is give it a really cool school-appropriate name, because we are going to hang these out in the hallway. And then you are going to just duplicate that grid, that table that we just filled out on the worksheet there that we were working on. Put that exact same table on your poster, except you're going to fill it in with all your own parameters. You can pick your own mass, you can pick your own heights, and 4 different positions on the roller coaster. So for example, I might say that my first hill, if I'm going to mark it off, maybe I'm going to make it 100 meters. And I'm going to make the top of this loop here, I don't know, maybe I want to make that 45 meters. And the end of my ride, that height there might be something like 60 meters. And you're going to pick 4 different locations on the ride, 1, 2, 3, 4, to have as your positions. So you would just label them 1, 2, 3, 4 down your table, and you're going to do the same thing. And you're going to have the mass, and you're going to have the height, etc., 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 just like the chart on the worksheet you just completed. And you're going to, fill it in with all the appropriate information: potential energy, kinetic energy, total energy, and velocity at each of 4 positions that you choose. So in summary, you're going to complete the worksheet first, then you're going to get in your small groups, 3, 4 at the most, and design your roller coaster. Talk about what interesting things you want it to do. Is it going to go through a shark tank? Is it have a break in the track? What kind of cool thing do you want it to do? Go ahead and draw that out on the poster paper that's provided. And I suggest drawing it out in pencil first. Go ahead and choose all the heights, just any random height that you want in meters, and pick 4 different locations. Top of the first hill is a must. You should probably do the bottom of the first hill as well, and then just 2 other places are fine. Mark them off, label all of the heights, and then make a table like we just did on the worksheet. Here's a key to the worksheet that you just filled out, so you can double check that you were calculating all of these values correctly. If you're stuck on this part, make sure you're getting help either from me or from your lab partner before you move on to making your own roller coaster, because until you understand this worksheet, you're going to have a hard time filling that out, designing your own roller coaster and then filling that table out. So make sure you've got all this correct first, and then go ahead and have fun with your coasters.